Greetings once again from Rescue Shuttle Control. Today's session will be a continuation of our last session in which we first learned how to access and use the OLED graphical display. Today we're going to take that basic information, that basic skill that we learned last time, and extend it to some more sophisticated applications. In particular, what we're going to do is go beyond the display of simple text static information, and we'll learn how to both display graphical elements and also animation. And to do so, we'll be using the U8glib that we learned about, the library functions that we learned about in our last session. But we'll be digging quite a bit deeper and using a greater variety of those functions and learning a bit more about how to use it. So the logic and the programming that we'll be using will be quite a bit more involved than last time, although we'll be using exactly the same hardware. And so for that reason, you can see that we have the very same setup of the OLED display and our hero as we had last time. No need to change that. So we will spend the bulk of our time today looking mostly at the code and the logic behind that code so that we can understand how to access and produce the kind of display behavior that we need for our applications. So with that introduction, we can jump right in and start looking at the code that we're going to be using and try to puzzle out exactly what it's accomplishing. Some of it will be fairly obvious, and some of it will take a little bit of digging in order to understand exactly what's going on. So let's go ahead and have a look. As you can see at the start of our code at the beginning, we have the include statement that includes the U8glib library that we learned about last time. So we don't really have to revisit that too much. And just as before, once we've got that library available to us, we can go ahead and define an object that accesses our particular OLED display. So you can see that we have chosen our 128 by 64 pixel OLED display and created an object that is any name that we want it to be. So in this case, we gave it the name My U8G Panel. You can give it any name you like, maybe something a little shorter or less cumbersome to constantly repeat. But I just named it something here that told us very clearly what it is so that we could remember it. And you can see that we've created this object reminding us that we're using a U8G display communicating over the I2C protocol that we learned about last time. So as we scroll down through our code, you can see that we've defined a new variable. This is an integer variable, an unsigned integer variable called drawState, and we've initialized it to a value of 0. And we'll see very soon what this variable is going to do for us. In particular, it's going to be important in controlling the behavior of our display as we increment through different settings or different displays that we show on the panel. After having defined that variable, we have a couple of familiar routines, our familiar setup and loop routine. The setup routine is really not doing much of anything special in this case, and so we don't have to spend too much time looking at it. The loop routine, on the other hand, is also quite simple, but it's important because just as in our last session, the loop routine is a picture loop. As it repeatedly executes, it's going to be refreshing material that appears on our OLED screen. And so we need to make sure that we understand what's going on in this picture loop because it's at the heart of what we're trying to do. Just as before, just as in our previous session, we have a do-while loop. And inside that do-while loop, which is constantly repeating over and over again, there are calls to our custom function that we need to provide called draw, which we'll get into very shortly. Just as in our previous session, the do-while loop continues to repeat until such time as the next page function of our panel returns a value of false or 0. At that time, the do-while loop terminates. That is the same as last time, and so far we haven't seen anything particularly new. What's different this time as opposed to our previous session is that that's not all that's happening in the picture loop. After the do-while loop drops out and we continue on down, there's more to do. And in particular, what we do is we take this variable draw state and we add 1 to it. Plus plus is the operator that increments that integer by 1. So it comes in as 0. After that, it's 1. And then after that, it's 2 and 3 and so on. So draw state will be continually increasing until it reaches a value of 72, 9 times 8. We represented it here as 9 times 8 for a reason that you'll see in a little bit. After draw state reaches the value of 72, something different happens. We set it back to 0. So this won't just continually increase forever. It will go from 0 up to 72 and then go back to 0 again. So we will have a number here that's basically going 0 up to 71, back to 0, and so on, over and over again. And you'll see why that's useful in just a little bit. That's what's new about our picture loop. We now finished the picture loop, and this whole thing loops as loop is always doing in our Hero or Arduino. All right, so the next question is, well, what is this function draw doing? And so that will be our next focus of attention. So let's scroll down and have a look at the routine that we've provided called draw. Draw does one thing at the very beginning, which is to call yet another function called u8gprepare. And you can see just below here that u8gprepare is a simple function that calls a set of preparatory routines for our panel, things like setting up the font and setting up the foreground and so on. So these aren't particularly interesting, but it's just a little bit of housekeeping that needs to happen before we start using the OLED panel. So what's really sort of at the heart of our discussion is what happens next. The next thing that happens is we use a switch routine. And if you haven't seen this coding construct before, the switch routine gives us the ability to move to different places in the code depending upon the value of the number that's provided in the parentheses there, the argument that's provided. So depending upon the value in the parentheses, if it's 0, we'll go to case 0. If this number is equal to 1, we'll go to case 1, and so on, all the way down to case 8. So the question becomes, well, how do I interpret the number which is in this parenthesis here? It doesn't look like a number, it looks like an operation's being carried out. And so we need to spend a little bit of time on this because it's a little bit subtle and it's a little bit maybe opaque at first, what's going on. Draw state, we know, can be a number from 0 up to 71. Now what we're doing with this double right arrow construct is this is what's called a bitwise shift. We're going to take that number and shift its binary representation 3 bits to the right. So you may ask, well, what does that do? And so a simple example might illustrate the binary representation of the number 8 is 1 followed by 3 zeros, 1, 0, 0, 0. If I do a bitwise shift of that 1 to the right, I now have 1, 0, 0, which is the binary representation of 4. If I bit shift it 3 to the right, then all I have is a 1. And so bit shifting 8 to the right 3 positions gives me back a 1. So what's happening here is that we're taking the draw state number and we're bit shifting it to the right 3 positions. So if it came in as an 8, it would come out as a 1. If it came in as a 16, it would come back as a 7. So what we're seeing here is the following. Every time a number comes in here, which is between 0 and 8, or between 0 and 7 actually, then the number in the parentheses here will be a 0 and will execute case 0. If it's then above 8, but below 16, if it's between 8 and 17, then this bit shift will give us back a 1, and so on. So you can see that what's happening here is that we are selecting groups of values of draw state, and depending upon what group it falls in, between 0 and 7, or between 8 and 15, and so on, we execute different cases here. You might ask yourself, well, wouldn't it be easier to just write some code that says, well, is this number evenly divisible by 8? And if so, what's the remainder of that? And use decimal arithmetic to figure it out. And you could certainly write the code that way. What we're using here, however, is using binary reasoning because it's usually more efficient and less computationally intensive to use bitwise operations as opposed to using decimal arithmetic. So it's perhaps a good practice for you to understand how this works and work through the reasoning of it. We're not over using bitwise calculations here because there's another aspect of it that's hiding in here that's also a little bit subtle, and so we want to go over it. Let's say, for example, that draw state bit shifted gives us back to 0, so we're executing case 0. We're going to call this function U8GBoxFrame, which is another function that we provided, which we'll go through down below here in a minute. And we're sending it a value. And the value we're sending it is not draw state. The value that we're sending it is draw state bitwise and with 7, which is the 3 digits 1, 1, 1. Now, depending on how familiar you are with binary bitwise operations, you may or may not immediately realize what the result of that bitwise AND operation is. But I'll tell you, and you can go ahead on your own after you're finished viewing this communication and maybe work it out yourself to convince yourself that this is the way it works. But basically what happens is that the result of doing this bitwise AND operation will always return a number between 0 and 8, actually 0 through 7. And then as soon as you go over, say, to 8, then it will go wrap back around to 0 again. So we'll constantly, as draw state increases all the way up to 72, we'll be successively going through 1, 2, 3, 4, 5, up to 7, and then back to 0 again. So we're going to be repeatedly calling these functions with those values going in. So once again, it's a sort of a clever and maybe a little bit opaque way of getting these numbers to go through values between 0 and 7 that we want in order to accomplish what we're doing. You'll notice that we have a total of 9 cases here. 9 cases are being exercised, each one of them with 8 possible sort of controlling values. So you can see where our 9 times 8, or 72, comes about as a sort of a heartbeat of this function and why it completely repeats itself after going through it 72 times. So with that explanation of what's happening in our draw function, we should go ahead now and try to examine what's going on in these separate cases. We've got 9 different cases here, and this would be way too long a communication session if I went in a detailed explanation through all 9 of them. But let's look more carefully at case 0 and understand it as well as we can. And then perhaps you'll have enough information to piece together on your own what some of the other cases are doing as well. So let's look at U8G box frame a little bit and see just what's going on. Let's scroll up to it. All right, so some of what's going on in U8G box frame should be familiar and some will be new. You'll notice that the first thing we do is something pretty familiar from our last session. That is, we draw a string. So we're going to draw some text information. In this case, we're just going to write at the origin draw box. That'll give us a little label that tells us what's going on. Next, we're going to use the function drawBox, which we haven't seen before. So what I'm going to do right now is I'm going to explain to you how we figured out what to do with drawBox. At the beginning of today's session and at the top of our code, I put a little comment in here. In your ship's library, you should be able to locate some documentation of the U8glib functions. Here's a URL that shows you where you can get the reference material on U8glib functions. Not just drawBox, but many, many different functions that you may be interested in. Here is the drawBox documentation. And I won't go through it in too much detail, but I'll just note that it tells us what we have to include as arguments. In this case, you'll see we have a nice example that shows that when we call U8G drawBox at 10 and 12, it starts to draw a rectangle with its upper left-hand corner at coordinates x equals 10 and y equals 12. The next two arguments, 20 and 30, in this example, tell us how wide and how high the box will be. So from that origin, we draw it across 20 and down 30. And that's how it should appear on our 128 by 64 display. A filled rectangle, a box, at that location in those dimensions. So when you're trying to decipher some of the other functions that we won't discuss here today, you can use this kind of documentation from your ship's library to figure out just what's going on in our example code. So let's look a little bit more closely now at what we're asking it to do with U8G box frame. So we are drawing a box located at 5 and 10 and is 20 wide and 10 deep. Next, we're calling another draw box, but this time we're drawing it at a different location and a different size. Well, what's the location? It's at a location 10 plus A and 15. But what is A? Oh, remember, box frame is having a number passed into it. And it's a number that's different every time because remember, it's derived from our draw state number. It could be a number between 0 and 7. So you can see that what is happening in this, let's get back to it here. A little bit too far. The first time through, it's going to be drawing it at 10 and 15. The next time through, it's going to add 1 to that, and it'll be 11 and 15. So this looks like a box that each time it's being drawn is being drawn a little bit farther to the right, a little bit farther to the right, and so on. And so this will be looking like an animation, a drifting box, as we successively display them. You can see that we also have another demonstration in this routine, and we're going to draw a string and say, okay, we're going to draw a frame. And you'll learn when you look at the documentation that draw frame works pretty much just the same, except that it draws a hollow rectangle instead of a filled one. So we have some idea of what to expect when this routine is run, and we should expect to see that run through 8 different positions of the box. In this case, the box looks like it's drifting to the right, and it looks like the frame is also drifting to the right as well as A increases every time it's called. All right, so in the interest of saving time, we're not going to go through all of these, but we'll quickly call out what they're doing before we go ahead and try and test our code and see if it's doing what we expect. When case shifts from 0 to 1, we're going to be calling disk circle. And so disk circle is going to be sort of like box frame because it's going to utilize the functions that allow us to draw a filled disk and also draw a hollow circle. And as A increases each time it's called, we'll see those disks and circles move about in some particular way. Let's go back and look at what's next. After that, we're going to be doing R frame. And if we go down and look at what R frame is accomplishing, we're going to be drawing a frame and drawing a rectangular box, and we'll be changing each time its size. So instead of a drifting box, this will be a box or a frame that's changing, that's maybe breathing in or breathing out, but it's changing its dimensions. It looks like it's increasing here since the A will be increasing each time. All right, what do we have? After that, we're going to be looking at string, U8G string. U8G string, if we look at it and see what it's accomplishing, it's going to be drawing some, you'll see, strings in different orientations, horizontal, 90 degrees, 180 degrees, 270 degrees. So that may be an interesting visual effect as we draw strings in different places and in different orientations. Let's see. After draw string, we'll be doing draw line. I won't go into too much detail on that. We'll be drawing lines on the screen. And you can go look at the documentation and see how we draw those lines in different orientations and make them move as time goes by. We have another case 5, which is going to allow us to draw some triangles on the screen and shift the shapes and sizes and positions of those triangles as time goes by. Cases 6 and 7 are both cases that are going to allow us to exercise a little bit more of our text drawing ability. So you'll see that we'll draw different ASCII text characters using these two routines. And then our last case is a kind of a last miscellaneous extra page. And actually, there's quite a bit of code in that last one. Let's see, where is it? Here it is, UG8 extra page, which is really irrelevant to us. This is a generic kind of example that was usable by color displays and by grayscale displays. And most of this is not going to do anything for us at all. As a matter of fact, the only thing our example is going to make use of is the last group of commands down here, which basically draw a string and then scale it up, scale its size up. And that might be a useful thing to be able to do. So that pretty much concludes a discussion of everything that we are expecting our display to do. And so now would be a good time, if you want to pause our communication right now and work through the logic, you can do that. But let's go ahead now and compile our code, upload it, and see if it has the expected behavior. So we'll go ahead and check the syntax here, verify that it compiles correctly. Looks good. We don't have any syntax errors here, so we've gotten rid of any really obvious mistakes. So let's go ahead now. Right now, we're not displaying this code because it hasn't been uploaded yet. You can still see the display from our last example. So let's go ahead, upload, and see, pay attention as it cycles through the different cases. Uploading now. And we should soon see rectangles and frames displayed. And there we go. We have draw box, draw disk, draw. Okay, so this is going by pretty fast. So let's go ahead and just pay attention to what's happening. There are boxes and frames, circles and disks, sized rectangles. You saw that we had orientation text moving. Here are our ASCII characters, and there's our scaled text. So it's displaying a little faster than I can speak, but you should be seeing all the behavior that we designed into our code. So there are the tilting lines, there are the growing and spreading triangles, there are different ASCII text characters, and there's scaled text. So there's a lot going on here, and you can probably spend a fair amount of time offline at this point working your way with the documentation, working your way through exactly how each piece works. But you should have enough information here to be able to figure out how this is working and maybe even do some custom modifications yourself just to test your understanding. We're gaining a lot of good skill, a lot of good experience at this point. And we're really getting much closer to the point where we'll be ready to power up your shuttle and be ready for interplanetary flight. So please review what we've learned today. And as always, build everything and invent safe.